So maybe I'll just spend 1 minute. So what I want to do in the talk is I want to give you a very brief introduction to the Lamarr Institute, which is one of the 6 new centers of excellence of research in machine learning and AI in Germany, which is in the institute is situated in Dortmund and Bonn. After doing that, I'll come to sort of the main point of the talk today, which is to give you an overview of some of the things we're doing in Trustworthy AI. And at the end, if time permits, I'll give some comments sort of coming from my classical computer science background. Let's see if I can make this work. Yes, so this seems to be going. Yeah, so before I got into computer science and mathematics, I was a pretty serious student of ancient Greek and Latin and philosophy, and so I liked to tie up with the image of Hercules and the Hydra. And in ancient Greek, there's this expression called Hydra.Lamarr in ancient Greek, which means cutting a Hydra, which I hope you can see on this wonderful vase from the 4th century BC. And if you go into the history of this sort of metaphor of dealing with this many-headed monster in terms of trying to solve complicated problems, then that went into the vernacular ancient Greek a very long time ago. Probably the first places one finds the sort of the vernacular kind of bon mot kind of use of this expression of cutting the Hydra, you find in Plato. And here I have taken one of the Platons in Plato, which is in Plato's Republic. And interestingly, the context there is to describe the impossible tasks facing lawgivers trying to, for example, put an end to frauds in business and other matters, like cutting a Hydra's head. And this is not very far from the problem as we're dealing with it today in our context. Now, of course, it's difficult to give a talk these days without also, in some form or other, quoting an LLM. And here is 2,500 years later, what Google Gemini says about creating trustworthy AI being indeed a Herculean task, because it's not a single challenge, but a multi-headed Hydra of competing requirements. Of course, I prompted the system a little bit to come up with this form of description, but what it then goes on to say is you need to break down the problem. And of course, this is true. What I will do today here is break it down a little bit differently, but still it's a breakdown of the problem. So let me just spend some minutes talking about what the Lamarr Institute is. As I said, it's one of the 6 new German research centers of excellence in AI and machine learning. And we conduct research in about 10 different research areas. I'll show you in a minute, consisting of about 60 professors and over 300 scientists, meaning PhD students and postdocs. As I briefly mentioned before, it's a collaboration between Dortmund and Bonn, involving the 2 universities in Dortmund and Bonn, but also 2 Fraunhofer institutes. In Dortmund, the Fraunhofer IML, which is one of the largest research institutes devoted to logistics in all its forms, and the Fraunhofer IAIS in Bonn, which is sort of the Fraunhofer Institute dealing with machine learning and AI. We care a lot about being part of a greater network inside North Rhine-Westphalia, the Bundesland, the state we're in. We have a network where we also support colleagues in other places in North Rhine-Westphalia. We work closely together with a research center called Trustworthy Data Science and Security, which is part of the UE-Ruhr Alliance, consisting of the 3 Ruhr district universities, Dortmund, Bochum, and Duisburg-Essen. And you may know, some of you, that for example, Bochum is really a world-leading place in security research. Also, the Fraunhofer ISST that I still belong to, as Faisal already mentioned, is also part of our network. Here you can see the directors, my colleague Ten Humpel, who is sitting at the third from, let's see, 1, 2, 3, 4. The fourth position from the left here is now retired. Alice Kirchheim is now the director of the Fraunhofer IML and is represented in the directorate of the Lamarr Institute. And Stefan Robel is sitting next to me here, who is leading the Fraunhofer IAIS. Christian Baukhage to the right represents the University of Bonn, and in the middle we have the Minister President of North Rhine-Westphalia there, also showing that we care quite a bit about outreach. We care about being part of sort of the European ecosystem of research. We look on the topic of trustworthy AI very much from a European standpoint, and we are interested not only, of course, in excellence in research, but also in transfer and education. And we have a commitment to sustainability, social responsibility, and ethics as well. So with that setting generally of the Institute, let me dive a little bit more into what we're actually doing in terms of topics. So the Institute is really founded on this idea that we call triangular AI, meaning that AI systems should not only be viewed as living from data, which is obvious, but also involving two other dimensions of knowledge and context. And so, for example, knowledge might lead you to learning representations, taking into account, for example, mathematical models, human expert knowledge in various forms, simulations, and so on. Context meaning, of course, the human context of use, but it might also mean the hardware resources, the architectures, and the real-world environments in which these systems are supposed to work. So the research areas are structured in sort of two dimensions. The first line here that you can see, hybrid machine learning, resource-aware machine learning, trustworthy AI indeed, human-centered AI systems, and embodied AI, meaning robotics. Those are sort of pervasive technological areas that you can find in many different vertical application areas. But then we have also so-called interdisciplinary research areas, which are more vertical. And the main areas are planning and logistics. As you saw, we have the Fraunhofer Institute, IML, in logistics there. We're very strong in physics in terms of doing a lot of work, in particular in astroparticle physics and particle physics. I'll tell you a little bit more about that as we move on. Industry and production, in particular manufacturing, virtual machining is an important topic of research in our institute. Life sciences, health, life sciences, meaning drug discovery, and health, meaning also clinical research. And natural language processing, which is what it says, but also encompasses, of course, large language models. Here's a little bit, this slide is in German, but I just took it with me here just to point you to a couple of things. To the left here, you see SOPHI, which is an open source European foundation model that we are contributing to. We have the Department of AI Assessment at the Fraunhofer IAIS for certification of AI, where trustworthy AI plays, of course, an important role, and which is part of the sort of application of the work that we do in trustworthy AI. We have a lot of work, in particular in Bonn, going on in basic robotics. They regularly win robotic competitions there, but also robotics, of course, plays a huge role in logistics. And so you can see these research areas have natural connections in many ways. Looking at the physics part, we have the IceCube project in astroparticle physics, which I'll say a little bit more about. We have a huge project, an excellence cluster called Color Meets Flavor in particle physics. And in all of these endeavors, machine learning actually plays a central role. Life sciences are already mentioned, but also work is going on that is relevant for agriculture. I like to use this example taken from physics just because it's something we're quite proud of, but it's also something which not everyone working in the area of machine learning might be aware of, that in fact nowadays machine learning is really an integral part of many areas of physics, in particular particle physics or astroparticle physics is here, because you're dealing there with huge data sets. And machine learning has really led to some fascinating breakthroughs of late based on machine learning techniques. The example I take here is from the IceCube project, which is a project running on the South Pole, where you got like a 1 square kilometer big mass of ice rafts sunk into the ground, 1 kilometer deep into the ground, and then equipped with sensor systems that constantly take in various particle events coming from the cosmos. And the problem here was to try to analyze these humongous data sets using AI. Was done in Dortmund from the physics group to a large extent in collaboration with colleagues from Wisconsin, and led to I think, a very honorable mention in the 2024 Nobel Prize report from the Swedish Academy, explaining why in that year a Nobel Prize went to the two pioneers in machine learning, Hopfield and Hinton, and the IceCube project was mentioned as one of the reasons why this made sense. Also, here's an example very briefly taken from life science, where transformer models are used to generate compounds and study special kinds of compounds of relevance to drug production. So with that, let me just also again highlight maybe the fact that we actually work with companies. The two Fraunhofer Institutes help us there quite enormously on the transfer side of things, but we're also engaging in teaching and education, not only promoting young scientist careers, but all the way down to the level of schools. We have large engagement from many people in the institutes. So now, with that first part, I'll now move to the second part and say something more about what we do in Trustworthy AI. And when I came to take over the leadership of the Dortmund part of the Institute a few years ago, I also was the chair for Trustworthy AI. I have a background in classical computer science. I've worked many years, as Faisal already pointed to, at Microsoft Research for about 8 years or more, working on verification, and some of those experiences I now bring into to this field. But one thing I did was that I started looking at the whole area of the Lamarr Institute, and it became clear to me that, in fact, every research area of the Lamarr Institute does serious work on trustworthy AI in one form or another. And I would say, since it's one of the, I think, the hallmarks, one of the USPs of the Lamarr Institute in particular, is that it has this intense interdisciplinary engagement with AI and machine learning research, reaching into the sciences and reaching into other fields, also including philosophy. In fact, we have the philosophy department represented in a significant way at the Lamarr Institute. I thought it would be an interesting idea to do the following, namely to sort of make a concerted effort to dive into the different ways in which trustworthy AI is being worked on, and to see if we could contribute towards an integrated and differentiated perspective on trustworthy AI, because it is a multi-headed hydra. And can we kind of help bring some structure into it? Can we inform the debate from the perspective of some of the application areas in particular, where we are looking at this problem of trustworthy AI, to help break down concepts and problems along a variety of application domains. And so this is really my main message for today, is what we're trying to do there. And so let me just give you a brief overview of how we're structuring this. I don't have time to go into a lot of details. My point here is just to leave you with an impression of where this might be going. It's ongoing work. I expect that the results of this project will be manifested this year, probably by the end of the year, by a publication that we intend to bring out on Springer about this project. And so as it is, what it looks like now is it's structured in three parts. The first part is about what is trustworthy AI. The second part comes from application areas where people work on trustworthiness in various forms. And the third part has to do with work on ensuring trustworthiness in AI. So the contribution from philosophy, I'm very happy that we have that because, as you can imagine, conceptual analysis and conceptual engineering from a philosophical standpoint helps us structure the enormous debates that are going on in various fields that kind of have this kind of conceptual direction. And there's a lot of different directions you can find there. I mean, you can find people saying from philosophical perspectives that, trustworthiness is a misnomer together with AI. It's a contradiction almost in terms, because, trustworthiness is something that you can only meaningfully attach to persons, and no AI is a person. So how do you deal with this whole spectrum of conceptual analysis around trustworthiness and AI? The role of explainability is massive, as you might imagine when you consider that we have a heavy engagement in various scientific fields. Explainability, of course, plays a big role there. But we going to have part of the work is going to dive into the role of explainability in different regulatory and also ethical frameworks for trustworthy AI. And I expect that we'll be able to contribute quite a bit of clarity by doing that analysis there. Resource-aware machine learning is a research area where we look at, of course, things like the duality between resource requirements and functionality. We look at things like sustainability, but we also look at automatic configuration and discovery and benchmarking of various machine learning systems in that context. And we bring that into the discussion on trustworthiness in this part of the work. We also have work going on motivated by the observation that we're really looking at a moving target. We don't know what the future is going to hold, and so can we somehow reach into the future by having a structured way of bringing in various kinds of expert opinions into the debate? So that's part of this work. Then I come to the column of work that comes from applications, and I already mentioned that life science is an important area for us. And an interesting observation to do there, I think, coming out of that work is going to be that indeed explainability and even more so causality becomes extremely important from that life science perspective in the context of predictive modeling and experimental design. That's really where causality comes in the most forceful way in the whole field. And this is something that surprised me a little bit, and it's one of the ways in which I think doing something like this can inform you. The health area, of course, is a supremely important application area. And of course, it's very interesting to try to understand what kinds of requirements on trustworthiness come from clinical practice. We work now with a number of major clinics in the area, both in Bonn and in the Ruhr district. And also, of course, this has to do with taking a regulatory perspective. One thing that surprised me a little bit there, which I thought was interesting, is that maybe in that area, you don't find, of course, quite as harsh requirements in terms of sort of the classical considerations from the philosophy and theory of science, like you do in life science. I mean, there is a certain tenet in some health application areas where you could sort of say, well, as long as it works, it may not be quite so decisive that we know exactly why it works. And you could actually, you have a long debate about that, and we're trying to help dive into that debate in the health area as well. Industry and production is concerned with trying to understand the role of explainability, in particular in the area of manufacturing systems, which has many aspects, and you go down to quite detailed levels of trying to understand what modern manufacturing, how that meets with explainable AI. Think of, for example, data coming out of sensor systems attached to various kinds of manufacturing devices, maybe bringing data at a very microscopic level sometimes, that then need to be analyzed in large quantities by AI systems to control the way these manufacturing devices act on some material, for example. Planning and logistics.
Sorry to interrupt.
Yeah.
Sorry to interrupt, Jakob, but we mentioned it before we start the seminar. Jakob, is okay to take short question, and I see there is one from Bertrand, and one from Bertrand.
No, I said that I can ask the questions later, just at the end. Don't worry.
Okay,
I wait until the end and I ask my questions.
That's all right.
Okay, excellent. So sorry for the interruption.
No, that's all fine. And if someone has questions, feel free to interrupt me via Faisal. He will do the interruption.
Thank you very much.
Thanks.
So then let me do it. Do it.
Yeah.
When you make advances in causality for the health and life sciences, do these advances easily transfer to other application areas?
No, that's a really super interesting question. That's really a key question. This you're hitting really the spot that was motivating me, because this is the sort of question that we want to be able to deal with once we have all the contributions coming in. In fact, I should say this collection is already it's really the outcome of a huge workshop, you could say. We've already had workshops. So the idea is that we're not just having separate contributions coming in. We have these people structured in groups that talk to each other and so on and so forth. Now, answering your particular question, I can't give you the answer of what the outcomes be, but it's going to be one of the things we're going to be looking at a little bit later in the year when these contributions are in, because then we're going to try to formulate some overarching perspectives coming out of these various areas. I think from my impression so far of the work, of course, there's going to be some highly specific things, for example, that the life scientists care a lot about, where you might say that doesn't transfer directly. But then other parts of it is certainly going to be transferable. The same thing you could say from physics. I mean, I find it super interesting, for example, to learn how does a physicist working at CERN, dealing with petabytes of data coming out of these LHC experiments per second, and using machine learning to conquer that complexity. And how do they think about, trustworthiness of their devices and the analyses coming out? And, could a radiologist learn something from that? Or could you, I actually expect that there will be transfer opportunities, but it takes a lot of work to identify them, right? And this is part of the kind of work that we're trying to do with this project. So it's a super relevant question.
Thank you, Jakob.
Yeah, sure. The logistics and planning area gives us an opportunity to study the problem also from a socio-technical perspective, because you're dealing there with, for example, the topic of having people working on the shop floor of a production site or a warehouse situation with, AGVs or drones flying around them. And how do you deal with trustworthiness in that context? Physics, I already mentioned quite a bit. There's a contribution on how you deal with the problem of trustworthiness when you use machine learning devices in astroparticle physics to do data analysis. And it turns out this is super interesting. I can't go into the details, but there's some super interesting insights about, in fact, certain techniques from machine learning not actually working according to physics standards, and then how they deal with that, for example, by bringing in confidence intervals to kind of rein in and correct or even reject things that come out of the machine learning models. Now, in terms of ensuring trustworthiness, there's a body of contributions coming from various perspectives. Didactics has to do with kind of using the idea of trust calibration and using trust calibration through education, trust calibration referring to the idea that, trustworthiness is not just a matter of maybe maximizing it, but it's a matter of reaching the right level of trust in humans towards various kinds of machine learning and AI situations. And so it also means that sometimes, it can be a problem that people under-trust some device that actually works pretty well in practice, but we're just too afraid maybe to use it and use it the right way. We have a whole department, as I mentioned already, at the Fraunhofer IAIS, which is led by Maximilian Poreczkin, and I understand some of you know Maximilian already. This is important work towards application, also touching on regulatory frameworks and assessing systems concretely in terms of, for example, the AI Act. There's another contribution coming out of physics in this area, which has to, in terms of ensuring trustworthy AI, the contribution I already mentioned touches it already, but this contribution is specifically about looking at simulation-based AI in particle physics. It's also a very, very interesting area because a lot of simulations, you use theoretical physics, give you mathematical models that you then can implement in simulation models, and you can then use those simulation models to train on synthetic simulated data, train machine learning models, for example, neural networks, which you then throw at huge data sets coming from the field, that is real data coming from the experiments and observations. And the methodology around that and what makes that trustworthy is an interesting topic. There's a contribution coming from philosophy and life science working together towards a normative framework for explainability. It's a very interesting piece of work comparing, for example, what does explainability mean in the philosophy of science, and what does it mean in machine learning, and how do these two areas actually meet when you try to think them together? That's very interesting. Human-centered AI systems has to do with the idea that, if you ask from a human-centered, a user-centric perspective for explanations, for example, a lot of the model-centric explanations that you get out of pure machine learning, like what's going on inside the model in some mathematical statistical sense, might be pretty useful for a user who useless to a user who foremostly maybe needs some sort of decision support. And so how do you bridge that gap? And then there is in the core field of trustworthy AI work that I do together with my colleague Daniel Neider, who's a professor of machine learning verification at the TU Dortmund. We're working on trying to give an overview of what's going on in verification of machine learning models. And with that, I will take a little bit of breather, just mentioning a number of contacts here. We have a coordinator, Thomas Liebig, is coordinating our work on trustworthy AI. So he would be an important point of contact next to myself. Also, Maximilian Poreczkin, I already mentioned, for AI assurance and assessments and assessments vis-a-vis regulations, for example, the AI Act, and etc. And Eva Schmidt, who's a professor of philosophy here at TU Dortmund, is helping us lead the work in philosophy. So I think I have maybe 5 minutes left or so. And again, you're welcome to interrupt me with questions if you have any. We'll take them at the end as well. I will now, at the end, venture a few perspectives coming maybe from my own background in what I would call classical computer science and verification in particular. Verification is the most radical tool, in some sense, the most radical attack on the Hydra you can imagine, because there, in verification at its core, you're looking for methods, and also you're classically looking at automated or semi-automated methods to essentially analyze a system and to produce a proof of some form or other that the system is okay with respect to a given specification or not okay with respect to a given specification. Of course, this is a super hard problem, and it was always a very hard problem, and it was always only applicable in particular restricted scenarios. But still, it's useful, I think, to ask the question, how much of Hercules we can get from verification. Of course, the problems of scale are there. I mean, verifying in any serious sense a large language model in some very general sense is out of the question, not just because of the scale problem, but also because what is the specification? We already know this problem from classical computer science. I mean, how do you specify an operating system? You can't. I mean, it's not even conceivable from a pragmatic standpoint that you could write down a complete specification of something like an operating system. Much less can you think of doing it with some large language model. The data-driven paradigm in machine learning changes the verification problem much. Of course, it turns the problem into much more of a stochastic statistics-informed problem. You have the black box problem. In classical verification, we wouldn't really talk about verification if we couldn't look into the way the system is built, in particular for software verification, looking at the code, or for hardware verification, looking at some kind of circuit design. And in many cases, we can't do that in the machine learning setting. We could do it in particular settings like what I call embedded AI a little later on. That is, we can think of, for example, neural networks playing part in some controller system. That's much more a classical scenario, even though it has machine learning, components, because there you could still derive specifications from the larger system requirements that you're embedded into. So that's a possibility, and that, I think, is a very important part of targeting for verification techniques. That still may matter. Testing will remain the predominant and pervasive technique, but now it's going to be, of course, even more informed by statistics. And in fact, machine learning itself, for example, think of generative adversarial methods are important. Some parts change for the better in the sense, for example, that in many machine learning contexts, you can talk about distributions over the input data to the system, which was something that would, in many classical scenarios, be very difficult to do. This simply has to do with the fact that we're dealing with new application domains where you can talk about distributions in a natural way over the input domains. A particular area that I think is interesting, but this is also colored by my own perspective on the matter and my own background, is code generation by LLMs. This is a topic that is taken very, very seriously in the United States, the way I read it. I mean, in some of the hyperscalers, where a lot of this work is going on, really, this application of, for example, LLMs to automatically generate code is taken very seriously. I see it not taken so much, not so much focused on this maybe in European research on machine learning, but I think this is an area that's very important. And the interesting thing here, from my perspective, coming from verification, is that in those kind of applications, the output produced by LLMs is actually something that can be understood as formal systems. I mean, code is a manifestation of formal system programming language and can therefore be formally understood. And in particular, it opens access to formal verification, not in the sense that you try to verify the LLM, but you take inspiration from something called translation validation and compiler verification, classical compiler verification, where instead of trying to verify the compiler, you try to verify each run of the compiler. That means you verify properties of each program that is being generated. And you ask, for example, is this particular program that the compiler spits out, is that actually equivalent to the input program? There's a whole line of work called proof-carrying code from that time in classical computer science that I think becomes relevant again. And in fact, it gets powered up by recent, over the past 20 years or so, of work in automating various kinds of logic, for example, in the form of SMT solvers, or you can think of theorem-proving systems like ROC-Lean. There's an enormous development that's been going on there. Of course, it's been standing a little bit in the shadow of the machine learning and AI explosion, but it's something that is really interesting to dive into if you're interested in these more kind of formal methods-oriented applications, which, for example, come into play with code generation. In general, it is sometimes possible actually to transfer work from basic science and formal methods into testing. I've done some of that work myself. In fact, you mentioned this award that we got from the computer-aided verification area. And in fact, that's a very interesting example, I think, of some work that started, in fact, as a theory of model checking, formal method theory. And then over the years, it actually became a big success in Microsoft in some of the testing environments, Coyote in particular. At the end, it had a lot of impact. Now, ending my talk, I will briefly just consider a couple of questions of a more broad nature. You could ask, coming from the classical perspective, looking back, is this whole business just another software crisis? I mean, we had it since the 1980s. Computer science was talking about there being a software crisis, and in many ways, at some point, it was sort of concluded, no, not really. I mean, there wasn't really a software crisis. You can have an interesting discussion about whether you think that's so or not. But in this case, actually, with trustworthy AI, I think it's very clear this is not just another software crisis kind of thing. This one is much, much broader and much deeper. And you also see that by the level of engagement that this topic generates in so many different fields, also outside of computer science. That's totally new. And so I wouldn't compare that at all. I also think, the geopolitical trust problem, one doesn't have to explain that. Just think about what happened a few days ago with the anthropic systems and so on, the geopolitical trust problem has become even more evident than it may already have been. And then at the end, the question I sometimes think about, how do we avoid repeating what I would call the industry user syndrome? That is the syndrome in Europe, that, European industries are mainly users of mainly United States and US platforms. I mean, this is a problem, right? Because first of all, you have this phenomenon that a lot of important research from EU migrates to the US, where it gets monetized. This is still the case in many ways, and also in some sense, in order to achieve impact, in order to really impact the systems, you in some sense have to be in the driver's seat, at least in those parts of the systems where you want to achieve the impact. I think all that said, that calibrated regulation from a European perspective, I think is necessary. But it needs to be informed by research on trustworthy AI. And I think also that vertical AI strategies are important for Europe. And I think in that context, it also is interesting to think about the work going on in data spaces. The Fraunhofer ISST is playing a leading role there in Gaia X and international data space initiatives. And so with that, I would end my talk, and thank you for your attention.
Thank you very much, Jakob, for this very interesting presentation. We now have time for questions. Feel free to. Yes, Bertrand, please.
Well, in fact, I have so many, many questions. Let me first say that I think I really appreciated your presentation, and I think that we should have more contact. In the past, we've had contact with IAS essentially through Stefan Wrobel and Maximilian Poretkin, and these contacts are still on, but we never realized to do a real project together. We have organized workshops together, we participated, etc. But I think that looking at what you're doing, I think that it would be really nice to have a really strong collaboration, like, let's say, for example, in European funded project or in Franco-German funded project. That would be really, really good. Yeah. Now, I have my first technical question is about the formal methods, because a long time ago, I tried to encourage people in machine learning and people in formal logic to work together. That was when I was at India, and I had people doing that in my research center. And I think I agree with you that it's something that should be pursued. Do you know if there was some time ago there was a first conference on machine learning and formal methods in England a few years ago? I don't know if this going on. If this is going on, if there are still conferences devoted to the subject.
Yeah, I'm not sure if I know exactly the thing you refer to, but I do know that there are several conferences and workshops now directed at that topic. In fact, the computer-aided verification community, which I have contributed to myself, which is sort of the hardcore verification community in classical computer science, they're doing a lot of work in this direction. So, in fact, there is quite a lot of work. There's work on benchmarking formal tools, on machine learning models. This area is really developing. Of course, if you compare it to the machine learning area at large, it's a niche, but it will always remain a niche. That's not a problem. Sometimes out of the niche, you get very important things. I'm saying niche because, I just had the experience of having a paper accepted to the ICML conference that's going to take place in Seoul, which is one of the world's leading conferences on machine learning. I know from the feedback from the organizers after the reviewing was done that they received, after vetting out all the nonsense contributions, only sort of the serious contributions, there were about 25,000 of them. 25,000 in one conference, right? So these are orders of magnitude that you're not going to find in formal methods on machine learning. But I think it's still important that we drive forward the logic-based work. I also think with the tremendous advances we're seeing in automated mathematical logic over the past 25 years, I think logic is going to come back and play a more significant role. It's already starting with things like, neuro-symbolic methods, which is, it's a fairly big thing in machine learning. And so we're going to see that area coming more to the forefront in various parts of machine learning again. Yeah.
Faisal, I have one or two other questions, but I think I will leave to others first. And if there is time, I will come back.
Thank you very much, Bertrand and Jakob. Yeah, we have time for additional questions. Fauzi, yes, please.
I think
Fauzi
is muted.
Are you hearing me?
Yeah.
Yeah. Thank you for this nice talk. Yeah, I have a question about in the philosophical side, the difference in your understanding about the explainability and interpretability.
Okay. So I don't want to kind of get into the depths of the contribution that we will see from our philosophers there. But so you say explainability and interpretability. I mean, in this contribution, if you read it once it comes out, you're going to find that question dealt with, I'm sure. I'm sure. Okay. I actually think the philosophical analysis is quite important and it's very helpful because there's so many ways of getting confused about what you actually mean by trustworthiness. There's so many facets to it.
Yeah.
But in the hands of a person spending their life doing conceptual analysis, they can help us to get some clarity there. Again, I'm a little reluctant to try to dive into the details of it, partly because I don't know them. I don't know what's going to come out of the analysis at the end. It's not finished yet. And in fact, when Bertrand said that we should do something, one thing I would certainly like to do is once this is done, once we have the volume complete, and we have more of sort of results that we can then bring out, I would like to maybe do that in some form or other once we're done with it.
Okay, that will be with pleasure.
Sure.
Thank you.
Yeah, thank you, Jakob. So from my side, if I understand well, you are referring to the publication that is still in progress. You mentioned which is expected by the end of the year.
Like there will be a Springer volume coming out of it. And again, I think the value add is that it's not going to be just a collecting, various inputs from various fields, but it's going to be more than that. It's going to be more of a concerted, unifying effort. I mean, we have workshops, and we're going to, once the single contributions are in, we're going to also write down some overarching perspectives building on that.
Yeah, we will be looking forward to read that.
I think it's a unique opportunity that this institute offers because it has so much interdisciplinary work, also including a deep scientific work in various fields that we can really get at. Yeah. And we can bring these physicists and so on together with the philosophers and have them discuss.
If I may add something on this matter, in fact, a few years ago, maybe for something like 3-4 years ago, maybe 5, there was a workshop at the Santa Fe Institute. Maybe you are aware of that one, which was called something like "What does it mean to understand?" or "What does it mean to know?" Something like that.
Yeah.
They published many of their conferences on a YouTube channel, and you had scientists, philosophers, and many kinds of humanities people looking at what is explanation, what does it mean to understand.
Yes.
And this was really very, very interesting. I watched most of the
pointer.
talks.
I will remember that. Yeah.
I go back to the YouTube and try to find the pointer for you.
Yes, I would be very, very happy to see it. Yes, thank you.
Thank you. Other questions? Still have time. Maybe I have one, Jakob. Thank you very much again for the presentation. Maybe a more general one. In the area of research, you mentioned to address trustworthiness as a multidimensional subject. Would it make sense maybe to talk about some sub area for which we would need to put more efforts than some others? You mentioned, for example, that it seems that generated codes by LLMs is something that works very well. And I'm wondering that, for example, other subjects like, I don't know, robustness, explainability, human in the loop, would you advise in that sense?
So, I mean, I think they're all important. I mean, the work on explainability is certainly important, but I think, for example, if you take explainability, I think what you really need there is digging into application fields to understand what does it really mean in this or that field, right? And so I think that's where it should be going. Dive into some of the, in a deep way, into some of the application fields. Like, for example, what are really the requirements from a clinical perspective? I mean, sometimes you're actually surprised when you talk to people working in a clinic. Like, you talk to a thorax surgeon about what does it mean in your case? You sometimes get surprised, and so that would be one thing I would advocate there. I think yes, the topic of code generation, I know it's a bit nerdy in many ways, but I do think it's something where we also have a chance to really do stuff in Europe. Of course, there is work going on it, but I just don't sense that it's being taken so seriously in many places as it probably should be. The work we do on logic in Europe is fantastic, but a lot of it only sort of really reaches impact once it's migrated to the United States, as I was talking about at the end. And so I'd like to see that changing a little bit.
Yeah, thank you. And I have another comment, questions in addition to this. If I understand well, at Lamarr, the area of research related to trustworthiness, I noticed that there is hybrid machine learning and from the other side, the human-centered systems. Can we see that as some kind of prioritized domains that?
No, I don't think so. No, I don't think so.
Okay.
I can tell you, if I understand your question correctly, I would see it differently. The one thing that became clear to me once I really dived into various areas of the Institute, once I started to take a global look, was the following: is that the research area that we call Trustworthy AI in the Lamarr Institute, and which I happen to be the chair of as well, that has some core work going on in verification, for example, also in philosophy and so on and so forth. But what really became clear to me is that this research area should be really understood much more like a not an area. It has more of a coordinating role.
Yeah.
Okay. Because when I look at what's going on, for example, on trustworthiness in life science or in physics in the Institute, that is so important that it needs to be really brought together with these other fields. So the fields you mentioned is clearly, they're there, but I see my role nowadays as leading the Trustworthy AI field in the Lamarr Institute. I see my role much more as a coordinator in some sense, and this is what I'm trying to do with this project that I was talking about.
Okay, very clear. Thank you very much again.